speakers, Russ, Pinizzotto, and Rob Burgess. So Russ is an amateur astronomer living in Phippsburg, Maine. His mother said he started looking at the stars while sitting on the back steps of his father's lap before he was even a year old. While he has a BS in chemistry and a PhD in materials science, he went back to school and completed an MS in astronomy online from Swinburne Institute of Technology in Melbourne, Australia. When not out observing, he's the interim provost at Simmons University in Boston. In fall 2021, he taught a new course called Women Astronomers of Boston, New England, and Beyond. Russ enjoys sharing his love of astronomy and with anyone who's willing to listen. Rob Burgess was enthralled with space as a young boy, growing up with Project Mercury, John Glenn, and the space race. At age 9, he was interviewed by his local paper for having watched his first lunar eclipse the night before. His father was a merchant sea captain, and Rob learned about some of the stars and constellations from his dad. Rob graduated from Colby College and went on to a career in law and finance. He's currently a senior vice president at Bangor Savings Bank, but he's remained keenly interested in astronomy. Rob has served as a NASA Solar System ambassador for more than 10 years, helping educate the public and school children about NASA exploratory missions. Rob is a founding member of Southern Maine Astronomers, and for the last 2 years has served as its president. He has a backyard observatory at his home in Brunswick and is always willing to share it with others who have interest. So we're really excited to have both Russ and Rob. Thank you both so much, and I'll turn it over to you.
Well, thank you, Ruth. I'm very glad to be here tonight, and we want to thank Kennebec Estuary Land Trust for inviting us and giving us this opportunity to share our passion. I'm going to talk the first part of the program, and we'll be talking about light pollution. It's going to be by way of fire hose, and then we'll move to a much more serene portion of the program where Russ will talk about the night sky, and hopefully that will be very enjoyable and more comfortable to listen to. But the program tonight is I wanted to talk about Southern Maine Astronomers. Just briefly to say that we're a group of amateurs. You've heard about us. We're a 501c3 founded about 18 years ago. We have a new home now at Brunswick Landing on, of all things, Neptune Drive. And we hold monthly star parties starting there in May through November. And membership in the club includes some magazine subscriptions and discounts, and a great sense of camaraderie with others who share the interest. And we're active in advocating for measures to control light pollution and preserve our dark Maine skies. Oops. Sorry about that. So what is light pollution? Very simply, it's misdirected or misused light that is generally resulting from an inappropriate application of an exterior lighting product like street lights or billboards, commercial building lighting, and it can also include residential lighting. It's lighting that goes beyond where it's intended or needed and has unfortunately some negative consequences. So what are the effects of light pollution? First, I just want to say, as a matter of context, we recognize this is not the most important issue facing planet Earth or us as a society. But one thing about it is that it is something that each of us can address personally, do in our homes, do in our communities, that can actually make a difference. And so for that reason, it deserves to be, considered an important thing, an important undertaking that we can all do and benefit from. I'll talk briefly about the impact on environments and human health, on sky glow and the loss of our cultural heritage, on safety and quality of life issues that can come from bad lighting, and economic and global consequences, including higher costs, taxes, and such things as global warming. In terms of impacts on animals and habitat, certainly all bats, most amphibians, mammals, and invertebrates are actually nocturnal. So while we turn on the lights, they're actively becoming more active in the environment. And that stray light can get into their habitats and have an effect. We know that migratory birds are often disrupted in their migrations by city lights and building lights. Many millions die from exhaustion and from collisions with buildings. We know that marine life, such as sea turtles, which I think everyone's probably heard about, when they hatch, they can be drawn away from the safety of the ocean because of nearby lights on properties and housing. Small fish and wading birds, their environments can be changed, and it can change the predator-prey dynamic. Insects are drawn to light and become easy prey. And while I used to think, who cares about bugs? I've become far more educated to realize many of these are pollinators and they're all part of the food chain. And if we disrupt it, we're going to have, some bad effects. So here are examples of, unfortunately, some of the bird kills that have been seen around major buildings and other aspects of what I've been talking about. There are effects on human health, and there is clearly a disruption of the circadian rhythm that our bodies operate by between when it is our bodies are to be awake and when they should be resting. And the disruption in that rhythm reduces the production of melatonin, which is a necessary hormone that helps protect us from various diseases. It's been learned that there are actually non-visual receptors in the eye that go to a different part of the brain than the optical receptors, and that trigger in us that start the bodily functions that are accustomed to waking up and going about our daytime business. And so those can be affected by light at night, and particularly light with high blue content, because it signals kind of a daytime sky. And this has been reported in a number of scientific journals. The AMA recently, a couple of years ago, did a report on the impact of excessively blue light in street lighting, because as a lot of communities were converting to LED lighting, they were using very bright white fixtures, which had a lot of blue in them. And I'll discuss that a little bit later. And I think it goes without saying that air quality is affected, because most of our electricity is produced by fossil fuel consumption. And as we burn more of that fossil fuel to generate the electricity that we are callously wasting, it is contributing to air pollution and more particulate matter, which can affect respiratory ailments such as asthma, lung cancer, emphysema, and things like that. In terms of our night sky and the loss of our cultural heritage, I mean, I think we've all seen the effect of glow over big cities, but even in small towns, we can experience that from point sources such as car dealerships or a shopping center, and that is overly lit and reflects up into the sky. So it's not just a big city problem. Whoops, I'm sorry about these slides jumping. Here's an example of a loss of an astronomical habitat. This is actually a picture of the Mount Palomar Observatory in Southern California that was built in the late 40s and early 50s. And obviously with the growth of San Diego, there is a huge sky glow dome in that vicinity anymore, which clearly impedes the ability of the observatory to perform all of the functions that it normally could have done or did do and was designed for. This is a worldwide light pollution map that comes from the New World Atlas of Artificial Night Sky Brightness. And it does reveal some remarkably disturbing aspects of light pollution today. It estimates that 80% of the world and almost 100% of the US and European citizens live under some level of light pollution today, and that the Milky Way is hidden from a third of humanity and about 80% of Americans who cannot see the Milky Way anymore. So, and light pollution is increasing at about 2.5% per year. Here's an example of a light pollution map from our local area. And you can see all the familiar communities from Boston all the way up to Bangor. And each of those little bubbles represent communities along the way. And obviously the darker orange and red lights are the most intensive light pollution, with that diminishing as you move towards the coast and eventually get out over the ocean. But you can also see up in the top right, I'm sorry about this, the around Baxter State Park and the Katahdin Woods and Waters National Monument, that those are some of the darkest skies east of the Mississippi. So Maine has some dark skies yet to preserve, and we should also be doing what we can in our existing communities to minimize the spread of light pollution around them. Light pollution leads to the loss of our cultural heritage and our sense of awe. And I think this is important. I mean, for thousands of years, humans lived under dark skies, and that was as much a part of their life almost as daytime activity. From that, they learned with the rising of certain stars or the setting of stars that it was a time to plant or a time to harvest. It led to the development of culture and mythologies. Religion was an inspiration for music and art. And I think most importantly, gave us a sense of humility to stare up into that vastness and contemplate who are we and what are we, what is our meaning in life. When you lose what's on the left and what you see is on the right, there's a lot of that awe that is lost because we can't see the stars. So that's a loss that we want to avoid. Safety and quality of life issues. I guess I would say, who hasn't experienced the dreaded blue headlights of an oncoming car? Well, the reason it's so bad is because blue light scatters more than other colors in the spectrum and ends up creating a lot of glare around those lights. And with Maine's elderly population, with us being the oldest state in the nation, elderly eyes are far more affected by glare than young eyes. I think this slide can help illustrate the issue. Is brighter lighting safer? There's often a debate when people talk about controlling light pollution and reducing the intensity of urban lights or town lights, that crime is going to increase. There has been no credible reported evidence of crime increasing in those communities that have made adjustments to the level of lighting in those communities. And I think this illustrates that having bad lighting is worse for public safety or the safety of maybe a police officer chasing a suspect. If he were to come around the corner and encounter these extremely bright lights, his eyes would constrict, shadows would darken, and the ability to see a possible assailant would be compromised. In a case like this, quality of place, is more lighting better? I really don't think so. If you lived in this housing community with these kinds of lights outside your windows, I don't think you would enjoy it. Likewise on the main street, someone made this renewal project. They put up an awful lot of streetlights. None of them is shielded, and light is flying in all directions, and it clearly is overlit. This is an issue that a number of people have brought up, which is the issue of light trespass. When the light from your neighbor's light strays onto your property or onto adjoining properties. It's a difficult issue to reconcile, and we can talk about that in the Q&A session. You may have a local ordinance in your town that would address this, but in most instances, residential lighting is not covered by many ordinances. And so it's a challenge to properly address this awkward situation between neighbors, but it clearly is a factor that affects quality of life. Economic and global impacts of light pollution. Outdoor lighting uses about 120 terawatts of electricity, which per year for street signs or streets and parking lots, which is enough to meet New York City's annual energy budget for 2 years. But the International Dark Sky Association has estimated that about 35% of that outdoor lighting is wasted, mostly due to poorly aimed and shielded fixtures, which adds up to billions of dollars of wasted expense and the release of 21 million tons of carbon dioxide into the atmosphere each year, which obviously has an impact on global warming. The issue of outdoor lighting and street lighting that has recently come up is the conversion to LED lighting. LEDs are wonderful things. They're far more efficient and we don't waste as much electricity when they're used. But if we install fixtures that are too bright in their color temperature, we will be throwing a lot more blue light into our environment, which is a bad thing. And so it's very important that when these conversions take place, that we select the right color temperature for the fixtures, for street lights and for commercial establishments, because they are so maintenance free. Whatever we install today won't need to be changed for a full generation. Here's an example of what I'm talking about. The correlated color temperature of these fixtures and these histograms is shown with a 3000 K lamp, 4000 and 5200. And you can note in the two on the right, the spike in blue light that is emitted by these fixtures is very high. On the left at the 3000 K level, the blue is substantially diminished. And that's why a lower color temperature is recommended for these outdoor fixtures. So what can you do? You can certainly connect with organizations that are working on this issue. International Dark Sky Association was established, I think, in the late 1980s, and it has been working tirelessly and effectively on worldwide light pollution with advocates all over the planet, trying to establish dark sky places and to control light pollution in their countries. There is an International Dark Sky Week that is coming up at the end of April, and we hope to have an event to get us out under the stars in celebration of that week, and that'll be up on our website if we are able to schedule such an event. There's also a group called Dark Sky Maine, which is an umbrella organization here in the state that brings together those who are interested in this topic to work on it from various aspects. So what else, what can be done by each of us as individuals? I think if you follow these guiding principles at home, you'll be helping out. And that is light only what you need lit, only when you need it, no brighter than necessary, using a warmer fixture color than around 3000 K or less, using a fully shielded or full cutoff fixture so that the light falls to the ground and not up into the sky. And to consider upgrading your outdoor lighting to dark sky friendly fixtures that IDA has established and puts on light fixtures that you can find in various, from various retailers. And finally, consider motion sensors for security lighting versus leaving lights on all night. What else can be done? Well, you can learn about your local zoning ordinances on lighting and recommend changes if necessary. I serve on the Brunswick Planning Board, and I've been working on this for a couple of years. And while we haven't yet revised our ordinance to include a limit of color temperature, we have been encouraging applicants who have come before the board for the last 4 or 5 years to limit their fixtures to 3000 K, and they have done that. But I note, interestingly, 297 pages of a new ordinance and 1 page dealt with light. I think light is like water pollution was 60 or 70 years ago, where no one thought about it. But I think we're increasingly learning that it does have an effect on habitats and on human beings as well. So follow developments in your town relating to streetlight conversion. You know, you can become an advocate in writing to elected officials and letters to the editor to encourage local discussion. You can participate in a citizen science program called Globe at Night Monthly, where you can actually go into your backyard, observe a particular constellation, and measure what you can see against star charts of varying magnitude, and confirm the level of ambient light pollution from your site, and record that through a website. And that becomes part of a scientific database on ground observations of light pollution. And you can, obviously join these organizations that I've referred to support their efforts. The State Planning Office, which doesn't exist anymore, but they did put out a publication in 2010 that actually has some very helpful things in it, and it is available online. The International Dark Sky Association also has a model ordinance on their website that you can refer to if you're looking for guidance. Finally, you can do things to promote Maine's dark skies as an asset. Remember that tens of millions of people live within a day's drive of Maine, and we know that 80% of them can't see the night sky effectively. So Maine offers some beautiful opportunities for ecotourism, we have in fact encouraged the Department of Conservation to make some of Maine's overnight state parks into dark sky parks at certain times of the year. With these kinds of changes, we can help our communities go from overlit gas station canopies to more properly lit facilities. We can take neighborhood streets and convert, very bright and light fixtures that are trespassing all over the neighborhood into a much more scaled down, serene, pleasant urban setting where the light is thrown down to the sidewalks where it's needed for people to navigate. We can go from into parking lots and outdoor community centers that have proper scale with light fixtures that are not too tall, that are illuminated at an appropriate level, and that have a color temperature that keeps the blue spectrum lower. And so I guess in summary, I would say that it's one of the easiest things each of us can do. We can save money, protect habitats, preserve our dark skies, reduce municipal expense, and help reduce emissions that contribute to global warming. Thank you for your attention. I apologize for the fire hose, but we'll turn over the program now to Russ, who will talk to us about satellites.
Okay, thank you, Rob. Really appreciate it. Really interesting. I hope everybody appreciates everything that you had to say. Let me share my screen. I'm going to talk about two things now. I'm going to first just give you a little bit about nanosatellites, and then talk about what you might be able to see in the night sky here. So let's just do this. This is an interesting photograph. This was from an observatory, a professional astronomy observatory. They were trying to take some what are called deep sky photographs, and they were photobombed. And the photobomb shown here is done by a constellation of satellites. These are the Starlink satellites that are being launched by SpaceX. And about every 2 weeks, they launch another 50 or 60 satellites into our skies. And right after sunset or before sunrise, these satellites reflect light, and it started causing really significant problems for astronomers. These particular satellites were put into low Earth orbit. They're only about 300 kilometers above the surface of the Earth. And the reason for this is for computer gaming, believe it or not. That is the primary motivation of this, that in low low Earth orbit, you have shorter delays and shorter time lags, and that is one of the things that Starlink is trying to sell. So this kind of photograph that was taken by this professional observatory is essentially worthless as it was done. These satellites do things like this. This will repeat a few times so you can watch it. So here's an observatory. This happens to be in Hawaii. And as they were observing in this general area, you see the streak coming by. This is speeded up time. That's a series of satellites coming by through the sky. And actually, if you go out at night, you can see these unaided eye. It's not that these are very dim, they are very bright. And you might wonder, what does this have to do with Maine? This is actually a photograph that was taken by one of the Southern Maine Astronomers club members, a person named Ara Jurahanian. And Ara is really one of the best astrophotographers that I've run across. This shows all the satellite tracks that came across the field of view that he was trying to photograph that night. He was looking at these, what are called dark nebula in here. And luckily, he has software that eliminates all the frames and does noise reduction and takes a lot of this out. But this is a real problem. Just to show you what we're talking about, let me share this with you. This is a website that shows satellites that are currently in orbit around Earth. And if we zoom in here, let me just do this, you'll see that there's an incredible number of satellites in orbit. This is low Earth orbit, up to a couple of hundred kilometers. And these are the ones that in the evening, right along here, actually reflect sunlight. And those are the ones that we see, and those are the ones that were in all of Ara's photographs that we showed you. One of the other things that I want you to look at is as we move out away from Earth, what happens is you see this really big band. And I'll highlight some of these big band out here. Those are all the geosynchronous satellites. So if you happen to subscribe to, let me just move this around. Do you see that band? It's like a belt that goes around the Earth. That's out at about 23,500 miles above the surface of the Earth. It's called geosynchronous orbit. It turns out that's where the orbital period, how long it takes one of these satellites to go around the Earth, is exactly the same as the time that it takes Earth to go once around its axis. So they look like they're stationary in space because they move around with Earth as we go. A lot of the TV programs, if you're a subscriber to Sirius XM, you're getting all your signals from these geosynchronous satellites. And these don't cause quite as many problems as those low Earth orbit satellites, but this is just to give you some idea of what's out there. This is a big problem. We as astronomers really are worried about this. There's noise not only in the optical range that we're talking about here that I showed you the pictures, but even for radio telescopes, this is even a big problem. These satellites happen to work in frequency bands that are very, very close to radio astronomy frequency bands. So it's a continuing big problem. So just wanted to take a few minutes and point this out to you. The diagram that I showed you had 20,000 satellites in it. SpaceX has authority to launch 40,000 satellites into low Earth orbit. They've so far have launched just over 2,000, and it's already a big problem. So imagine another 20 times that many satellites in low Earth orbit. And that's only one of the organizations that has permission to launch this many satellites. There's another group called WebX that has permission to launch 10,000. The Chinese have plans to launch another 20,000, et cetera, et cetera. Altogether, there's permission to launch into low Earth orbit on the order of 100,000 satellites. So if you can imagine what I just showed you times 5, this is a serious problem. And it's a serious problem because you can see them unaided eye. A lot of times when these satellites go by, if you know what the time is to look, you don't even need binoculars or anything. You can actually see them unaided eye, let alone with a telescope. So just another problem with pollution of the night skies due to a little bit too much light up there. Okay, but let's talk about something that's a little bit more fun instead of all these other things that we've been talking about. So let me share my screen with you for this. And let's just talk about what you might be able to go out and see. So hopefully you can all see the night sky now. This is a planetarium program called SkySafari. It's one of the ones that I use all the time. This happens to be if you happen to be looking north. And if you look carefully down at the bottom here where my cursor is, it says N for north. But up here it says the zenith, which means straight up. So right now this diagram shows you what you can see from the horizon, which I live in Phippsburg, down the peninsula, and I can actually see the Milky Way. And I can see things down to less than a degree from the horizon, all the way up to the zenith. So if you look up near here, it just says there's the zenith up there. Hopefully you recognize something looking north. I hope that is true. If you've ever looked for constellations, and the constellation that I hope you can see is this one right over here. This is called the Big Dipper. Okay, and right now at this time of year, I have the clock set for April the 2nd, which is Saturday night at 9 o'clock. You might ask me, why did I pick Saturday night at 9 o'clock? Because it's supposed to be clear. And hopefully all of you will go out and look to the north and find the Big Dipper right here. And let me show you one of the things that I can do is turn on the constellations. Does that help? Hopefully that helps. So here's the Big Dipper. The Big Dipper actually is an asterism. It's only part of the constellation. It's part of the constellation called Ursa Major, or the Big Bear. And so here's the Dipper part. But the Big Bear is a lot bigger and has the rest of his body and his nose and actually has his legs as part of the constellation. One of the things about the Big Dipper, these are called the pointers. And the pointers point to Polaris. And Polaris is the North Star. Now, let me point out that the North Star is not the brightest star in the sky. A lot of people think the North Star is the brightest star in the sky. It's not even close. It's less than the 50th brightest star in the sky. So it's even dimmer than the pointers are. It points down to Polaris, and Polaris has the Little Dipper right here. You can see the Little Dipper. This is much fainter than you might expect. And in light polluted skies, you can't see it. So it's a real problem. I happen to also, as you heard, I work as the provost at Simmons University in downtown Boston, and I live in an apartment very close to the campus. When I go up to the roof to do observing, I can see maybe 8 stars total. And I can barely see the Big Dipper from downtown Boston because of the light pollution that Rob has talked about previously. Let's talk about a few other constellations that you can see. So I'm moving, so you move. So instead of looking directly to the north, you spin towards your right and you're looking to the northeast. The Big Dipper does look like he's standing on his tail. I know one of the questions was, what did the indigenous peoples, do they have different stories and different constellations? Absolutely. These constellations are primarily Greco-Roman, and the indigenous peoples had totally different stories. One of the questions is, why does a bear have a big long tail? Bears don't have tails. I mean, this is bizarre, right? This is just one of those things, and there are stories about one of the gods grabbing a bear by his tail and swinging him around his head and throwing it into the sky. And as he did that, his tail got stretched out. Well, that's a Greco-Roman myth. Indigenous peoples in North America don't see these 3 stars as the tail. They see these 3 stars as 3 hunters chasing the bear. And this particular star right here actually is a double star, and it's used as a really good test of your vision. If you can go out and actually see this as a double star, and I will zoom in on this for you. See, it's a double star. They're 2 very close together. In Arabic, this is called the horse and rider, Mizar and Alcor, which is Arabic. It turns out that a lot of our star names are Arabic derived because they're the ones who kept up doing astronomy during the Dark Ages while Europe was doing essentially nothing. And so we don't have a whole lot of records from Europe. We have a lot of records from the Mideast because they were doing astronomy. So you can go out and see how good your eyesight is, if you can see that as a double star or not. Looking at that, looking at the tail, what we like to say is you arc. See, this forms a little arc. You arc down to this very bright star. It's called arcing to Arcturus because this star is named Arcturus. And there's the kite. It's part of a constellation that looks like a kite on its side. Does that look like a kite to you? So that's the constellation Bodes, which is the herdsman. Below that, which would be hard to see unless you're in a dark sky site right now, is this little arc. It's called Corona Borealis, which means the northern crown. Students like to think of this as a pizza with one of the slices missing. Okay, so you can think about it as having an ice cream cone instead of a kite and a piece of pizza missing from a whole pizza over here. After you arc to Arcturus, you spike to Spica. And this is this is also a very bright star. It's bluish. These give you some idea of the colors. And this weird looking constellation is actually Virgo. And it's one of the constellations that's in the zodiac. Directly above Virgo is a constellation. This is one of the few constellations that actually looks like what it's supposed to be. This constellation in here is called Leo and the lion, and it actually does look like a lion lying down. This big, long, dim constellation over here is a big snake. We won't spend too much time on that. So after you're done looking and finding all those constellations to the north, you should look to the south, spin yourself around, and then look to the southwest, and you'll find a whole series of stars down here that are really interesting to look at. You'll find these three really bright stars in a row. That's Orion's belt. That led to all the confusion in Men in Black, if you remember about Men in Black and Orion's belt being actually the collar on the cap. Well, they thought it was this line of three stars. That's called Orion's belt. And you can go around in a circle and see a whole bunch of really bright stars. Here's the circle, starting from Orion's belt. If you look towards the middle, this is the star that everybody laughs at its name because it's Betelgeuse, okay, which does not mean the armpit of Orion. It means his shoulder, but everybody likes to think about it as an armpit. Underneath the belt is this star, which is called Rigel. And as you go around, this is the brightest star in the sky. It's Sirius. And if you've ever wondered why Sirius XM has a little dog as its logo, it's because Sirius is also known as the dog star. And so Sirius XM Radio adopted the name of this star and also the little dog logo, if you ever look at Sirius XM. As you look up into the sky, you come to here. This is Canis Minor. The dog star is in a constellation called Canis Major, which means the big dog. If you move up here to the next, this really bright star is Canis Minor, which is the little dog. In between is a funny little, really dim constellation that's a unicorn. And you may not have known there was a unicorn constellation, but there really is. It's called Monoceros, which means one horn. You move up, you find two stars up here. And as you might expect, because there are two stars, this is the constellation Gemini. Right up here, continuing around, you find this star. That star is called Capella. There's an online university called Capella University, which named themselves after this star for some reason that I don't understand, but they did. So that's Capella. And then as you move back down, you come to this star, which is Aldebaran. This is in the constellation Taurus. And then you come back to Orion. So if you go out and you look to the southwest, what's really cool is not only can you find Orion, but you can find these other constellations by looking through that circle. And it's Canis Major, Canis Minor, Gemini. Capella is part of a constellation called Auriga. Aldebaran, which is part of Taurus, which is the bull, and back to the foot of Orion. So just going and finding the Big Dipper and then finding these stars in the southwest, you should be able to identify like 12 or 15 constellations. They're not really that difficult to figure out. So kind of fun. The last thing I want to tell you, though, is that night after night, things change by 4 minutes. So everything gets moved forward by 4 minutes. So I told you that this was showing you on April the 2nd at 9 p.m., which is Saturday. If you go out for the 3rd, it's this, the 4th, the 5th, the 6th, the moon starts coming up, 7th, 8th, 9th, 10th. So if you wait, by the end of April, you're not going to be able to see all of this. So you should go out on Saturday night, this Saturday night, supposed to be clear. Go out on Saturday night, find the north, find the Big Dipper, arc to Arcturus, spike to Spica, turn yourself around 180 degrees, face the other way, find Orion's belt, and then go around these constellations before they go away. Okay, so there you go. That looks like it might be a little more fun than worrying about nanosatellites and nanosatellite constellations in the sky. I think we're open for questions, right? At this point, for either Rob or for me.
Yeah, that's awesome. Thank you so much. So we did have some questions come in over chat, and I'll read those out. I guess one that came in, and I guess this one was sent earlier, was what are you looking forward to when the James Webb Telescope becomes fully operational? I'd love to hear about that.
I'll tell you what I'm looking for, and I don't know what Rob will say. That telescope will enable us to look farther back in time than any other telescope. It has been designed specifically to look at what is called infrared radiation, which is how light gets stretched out as it travels through time. A lot of us in astronomy like to think we deal with time machines because everything that we look at in the sky is not as it is now, but as it was sometime in the past. The stars, the individual stars that we see are relatively close, and by relatively close, I mean we measure their distances in thousands, tens of thousands, hundreds of thousands of light years. So we're looking at a lot of those stars as they existed 100,000 years ago, not as they exist now. But with the James Webb Telescope, we're able to look back close to 13 billion years, and we'll be able to see what the universe looked like relatively soon after it was first formed. That's really exciting that we might be able to get some data on how the universe actually started itself up.
I think one other thing that Webb is going to help us with is exoplanets and zeroing in on some of those candidates that might have characteristics similar to Earth, where liquid water might exist on the surface and they're close to a stable star that allows the evolution to possibly occur on those planets. One thing I think Russ mentioned it, just so people understand that the electromagnetic spectrum, which runs from gamma rays all the way down to radio waves, we only see a tiny sliver of that with our eyes. But there's a whole bunch of other things going on in the sky that are real, but we can't see them because our eyes are not designed to look in those frequencies. So the James Webb is going to work at one end of that down at the infrared level, but we've also had orbiting observatories that have worked in the gamma ray and X-ray and ultraviolet ranges, and so this is the latest and a remarkable engineering achievement that we can all be proud of, and we expect first light sometime in May or June.
Yeah, I think one of the things people don't really know is that the Hubble Space Telescope was part of what was called the Great Observatories. And the Great Observatories included all those other space telescopes that Rob was just talking about. There's a series of 6 of them that covered everything from gamma rays to infrared. They were all specialized for one particular part of the electromagnetic spectrum. Human eyes have evolved so that our eyes work best. It just turns out it's by accident, right? Our eyes work best at the wavelength, the maximum output of our sun. So it's a very, very narrow band that our eyes actually work well at.
That's really neat. Thank you both. We had a couple of questions come in about technology. And so one was about the site, Russ, that you were using. I know we'll be sending out a list to all the participants with the resources you shared, but would you mind naming the what program was it that you were using to look at the
Sure.
stars?
So the planetarium program that I use every time I go out observing actually is called SkySafari. It's available for iPads and iPhones. I'm not sure if there's a Android version. I just don't know because I'm a Mac guy for the most part now. So I have it on not only on my iPad and my iPhone, but on my computer as well, my Mac. So it's called SkySafari. I think they're up to version 7. You can some of the versions are relatively inexpensive, like $10 or something like that. And then there are some more expensive ones that, like SkySafari Pro, which is the one I use because it goes down to magnitude 18 or something like that are more expensive. But it's relatively inexpensive to get started. SkySafari.
I would also add, if you go to the search engine in the App Store, there are a number of other ones out there. I happen to use SkySafari as well, but there's one called Stellarium, which is free. And that is, there is a cell phone version for that and for a desktop or laptop computer. And that's a free one. And then there's a website called skymaps.com, which produces a sky chart monthly of what you can see from our latitude generally. And what's nice about that is it shows the full sky, and you can look and see what's up in each of the 4 corners, northeast, southwest, and overhead. And on the back side of the form, the second page, there's a list of naked eye objects to look for, binocular objects, if you have a pair of binoculars, and small telescope objects. And that's free.
Thank you.
I know, Ruth, there was a question about are there any special events this spring? The answer is yes. There is a lunar eclipse on May the 15th. And just to show you what that might look at, if I could just share my screen again just for a minute, let me show you what that might look like. So here's the moon down here. Everybody see the moon? What I'm going to do is I'm going to speed time up, and every time it jumps, it's 1 minute. So if you look at the moon, maybe I'll make it just a little bit bigger. Just a little bit bigger. Let me show you what happens. There we go. There we go. The shadow of the Earth comes by and covers up the moon. It starts at about 10 o'clock or 11 o'clock at night, and then goes to like midnight or 1 o'clock in the morning. So if you're really into amateur astronomy, you get used to staying up late at night. So, but May the 15th is a lunar eclipse that we can see from Maine.
I know the Southworth Planetarium is talking about having something on campus, and has invited us to be part of that, and we may do that. But this is something you can enjoy from your backyard. And if you haven't seen one, it is so remarkable, because once the moon is fully eclipsed, it turns red because of the light coming through the Earth's atmosphere and illuminating the lunar surface. But it gives it a unbelievable eerie 3D dimension, where the moon actually seems to be sitting above the plane of the sky behind it, and it's really quite exciting. So I would recommend it if you haven't seen one.
Would you recommend, is SkyChart a place that you'd go to find a list of events like that, or are there other places that you go to look for neat sky events that are coming up?
Go ahead,
Rob. Well, I was going to say, if you look at Sky Maps, Sky Maps is done every month, and it has events for the entire month. All the lunar phases. It definitely would talk about the lunar eclipse. It talks about what are called conjunctions sometimes, which are real when planets and the moon or planets themselves get close to each other. So Sky Maps is a really, really good place to see that. But there are a number of websites. If you just type what's up in the sky in astronomy this month in Google or something, there are lots and lots of websites that do this.
I would also recommend that something that we're affiliated with is the Night Sky Network, which is a NASA supported website that's actually administered by, I think, the Astronomical Society of the Pacific, I think. But they have monthly What's Up videos and all kinds of things. So it's just Night Sky Network, Google that, and you'll get there.
Thank you. We had a couple events or a couple of questions related to satellites, and one was asking if they need to take satellites down eventually, or do they just fall down? What's the process?
It's a little bit of both. So some satellites just decay on their own. There are lots and lots of dead things in orbit, and some of them just because of drag because they're even in low Earth orbit. There's still, even though there's not very much air, there is a tiny little bit, and it slows things down. And our atmosphere will bring them back down eventually. The problem with that is we don't know where they're going to land. Luckily, a lot of them land in the ocean because the Earth is primarily ocean and not land. But there have been incidents of things crashing around. Other satellites are brought down under control. So some of the SpaceX satellites, the first 60 that they launched were launched as test objects, and they had enough fuel that they could deorbit them on purpose and crash them. In fact, there's a place in the southwestern Pacific Ocean called the Graveyards of Satellites because it has the largest distances to any landmass, any islands or any people. And so when people purposefully bring satellites down, they tend to bring them down to the same location in the southwest southern Pacific Ocean. So some of them we bring down on purpose, some of them we don't. So it's a little bit of the above. There was another satellite constellation called the Iridium satellites that were satellite phones, not the same thing as Starlink. These were just to have satellite phones. And they're on version 2, and they brought, the version 1s have all been brought down on purpose. But some of them go out of control and they fail. Not every satellite launch is a success. And there are still version 1 Iridium satellites in orbit that aren't controllable. And they'll come down whenever they come down. So it's both.
And sometimes nations choose to shoot them down to test their military prowess. I mean, the Russians recently blew up a satellite. The Chinese have done that. And what they've done is contributed thousands of pieces of space debris. That recently, people at the International Space Station had to take protective measures because there was risk of some of that debris actually hitting the space station. And even if it's a small piece of metal, it's traveling at nearly 18,000 miles an hour, which can do real damage. So there have been some irresponsible removals of satellites.
The space station has to maneuver about once a week. It uses up fuel and it uses up time, and it's because of all the space junk. There is a theory that, and we're approaching this, believe it or not, where there will be so many pieces of space junk because when one hits another one, then it generates thousands of more pieces, that it will be catastrophic. That there will be so many pieces, I can't remember what they call this, but there'll be so many pieces in low Earth orbit that it'll just start self-destructing everything in low Earth orbit. And we're getting close to that event. And there are people who are seriously concerned about doing that. There have been accidental collisions in space. One of the Iridium satellites that I talked to you about crashed into a dead Russian Cosmos satellite and generated 10,000 more pieces of stuff in space. Yeah.
That's pretty wild. What happens to the ones that wind up in the ocean? Do they just let them sink, or do they retrieve them?
Yeah, they're gone. No, they sink to the bottom. They're gone. They just splash, and there you go.
The atmosphere does take care of a lot of it. I mean, a lot of the stuff burns up before it ever impacts the surface. So I don't know how much is down there, but you know, at least there is sort of a self-cleansing mechanism by friction.
Yeah.
We did have a question about light pollution. Someone was, Rob, you'd mentioned a number of different things that the light pollution disrupts, and someone was wondering, what about plants? Does it interact with plants in any way?
Oh, it does. That's a very good point. Trees will hold their leaves longer, and they will also bud sooner because of lights. So it does have an effect on, you know, that kind of larger vegetation. Whether or not it affects other things, smaller plants, I'm not sure, but it certainly does. In an urban setting where there are street lights and things, it does have an effect on their life cycle. That's been chronicled.
I think that's it for questions. Becky, are you seeing any others?
I have not. If anybody has a final question they want to squeeze in right at the end, feel free to type it in now.
Just say that if people are interested, and given, I'm not sure where the audience for tonight lives primarily, but if they're in, you know, close to the Kennebec estuary, you know, we're in Brunswick, and we hope to be holding star parties starting the middle of May and running for maybe 6 months a year throughout the year to November. You know, check out our website and we'll have those events up there. We've also been invited to participate in a number of other organizations' events over the course of the year. And we have been doing star parties with the Cape Elizabeth Library, believe it or not. Russ, along with one of our members, has done a real-time imaging of nebulas and galaxies from his observatory in Cape Elizabeth, feeding it live into a Zoom call and showing images that are you know, coming down as more and more pictures are being taken of that object. So Russ has been part of that team to produce those events, and we've done 2 of them and others are scheduled. So that's the Cape Elizabeth Library has that outlet as well.
That sounds awesome.
Yeah.
I think we're scheduled to do those every 3 months. So we just did one in the beginning of March. So I guess the next one will be sometime in June, if they're willing to wait till it's dark.
We did get a grant from Bangor Savings Bank Foundation to purchase some equipment to enable us to do exactly that. And it was designed around COVID, when everyone was, you know, particularly worried about sharing eyepieces. So we came up with a plan to enable people to be outside with a telescope that was projecting what it was receiving in its camera onto a screen, and people could stand around and watch that image develop over a period of 10 or 15 minutes, and then have a discussion about what they were seeing and an explanation of the object. So we've got that capability now, and we will continue to use it, COVID or no COVID, into the future.
That's awesome. Thank you so much, Rob and Russ, for taking the time to talk with us and sharing all of this really neat information. It was really fun to look at the constellations with both of you, and looking forward to learning more. I'm hoping to join a star party at some point. For all the attendees, we'll be sending out the recording, and we'll also be sending out contact information for the Southern Maine Astronomers and some of the other resources that were shared tonight. So thank you again, and I hope everyone has a great night.
Thank you.
It's been a pleasure. We appreciate it.
Thank you very much. Have a good evening, everyone.